Cool. So we got how many people? We got 43. It's pretty good. I think I'm just gonna start now. And there's some concepts I want to go over too. So we can spend some time on that while people join. So quick intro. This is an idea I had a while ago to do one LeetCode question per week within the group to as a way to get people to get familiarized with it, get people exposed to it if you haven't done it before, or if you have done it before but you're kind of rusty, get you back into it. That's why we choose the easy questions. And when I say easy, let me do a quick screen share. And I hear some kind of echo. So can you mute if you're not talking? But also feel free to ask questions anytime, or just mute by default. All right, should be sharing my screen. So yeah, for anybody who's not familiar with it, by easy I mean like the easy classification on LeetCode. And don't get confused by this. It doesn't mean that it's actually easy. It really depends on where you're at. So if you know the concepts, like if you know what trees are, binary trees, how to traverse them, and if DFSs and stuff like that, then it's going to be easy. But if you don't know those things, it's going to be hard actually because you kind of have to reinvent the wheel, which nobody expects you to kind of figure this out if you don't know those fundamental things. It's like if you're trying to take a math test and you don't know how to do long division, we don't expect you to figure out how to do long division on the test. I feel like that's the kind of impression I got when I first started doing this, when I couldn't figure things out. I was like, maybe I'm just not getting this somehow. But then I learned some specific concepts and patterns that you need to know to be able to solve this. Because you're not going to come up with it on your own. You got to learn these beforehand. And that's when it started to get easier and easier. So I'm going to walk through some of those concepts. It's not going to be like a full, thorough walkthrough. So some people might get lost, might not. But ask questions if you do. And I think regardless, it's still good to have this. It's recorded. You can go back to it. And I can share some resources after this to follow more like things like DFS and trees and so on. So before I jump into this question, so anybody have any questions? All right, and I have a question for you. How's my audio?
It's good.
Good. I can hear loud and clear.
Nice. All right, so let's start. We got 67 people now. Okay, good. So about 20 more people join in. So I'm gonna read this and then try to I'm gonna kind of take the role of I'm just doing this question and I'm gonna just tell you my thought process as I'm doing it. And feel free to jump in with any questions or insights along the way. So have some. Given the roots of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values on the path equals target sum. Now this is kind of like a mouthful, but breaking it down, given the roots. So the root of a tree, for those who don't know, basically is the top of a tree, where there's no parent to that tree. And the root really depends. So if you look at number 4, that's the root of this subtree of like 11, 2, and 7. Can you see my mouse as it's moving along?
Yep. Yes.
Okay, perfect. So yeah, so number 4 theoretically is the root of a subtree that has 11, 7, and 2, and so on. So as you'll see in the code, root is going to be referred to in cases where it might not seem like it. This is the root, but that's the reason why. So going back to the question, the root in this case is 5. In this small example, is a target sum. In this
Sorry,
example,
Esther, can you ask the people to mute? I can't hear you clearly.
Yeah, so can you mute? Let me see. I think there's a way to mute everybody.
I said, yes, she's lovely, but I want you to do the
So for those, let me see, where is that? Maybe I can see it on the list.
I said, oh, he said, it's fine. I finished it once. I just forgot to teach you. And he said, I'm so down to that.
1 second.
He said, and I said, God, either I need lady training or you really are a little slow. And he said, you don't need no training. I'm just slow with text, man. Allow me. And,
okay, yeah, I can do it one by one. All right, I think we got it. All right, cool. So again, feel free to unmute if you have a question. So going back to this question, I hear something again. Oh yeah, you don't need to raise your hand or Mokoro. You could just ask the question.
Oh yeah, I just wanted to suggest probably you make a couple of people co-host so they could help you manage the audio because so it won't get interrupted. And
Oh,
that sounds
nice.
like a
That's
more
a good
good.
idea. Oh, I
Yeah.
just changed the host instead of made it a co-host. Can you give me back the host? I just give it to you.
Oh, oh, my bad. Okay, hold
Yeah.
on, let me do
So
that.
I didn't see a button for co-host, so I was confusing you.
Yeah, yeah.
Okay, thanks.
So I've handed
Let
it
me
over.
see how to find that. It's weird. I don't see any button for a co-host, but I know when I first created a meeting, there was an option to put email addresses. So for next time, I'll do something like that. But for now, I don't see if there's a way to do that. All right, let me just go ahead and share my screen again. All right, so given the root of the binary tree, the target sum, in this example, target sum is 22. Return true if there's a root to leaf path. So root to leaf path in this case is what they highlighted in blue. Starting from the root, which is 5, all the way down to a leaf. And for those who don't know, a leaf is basically a node with no children. Each of these little circles here is a node. The ones at the very bottom that have no other nodes coming up the left and the right, those are called leaves because basically there's no children. And that's a term we use for it. I guess it's kind of like when you have an actual tree that has branches, and then each branch has multiple smaller branches that have different leaves on it. But then when you get to the leaf, there's no other branching coming out of that leaf. I think that's probably why they call it a leaf. It's like a play on words with trees. So yeah, now it's a bit more clear, kind of saying it that way. You have a tree starting from top to bottom on any one of these paths. Does it sum up to the target sum? And the thing about trees is, if you go from 5, 4, 11, 2, we're not really saying a path is 5, 4, 11, 7, and then 2, because you got to go backwards. We're just going straight. Each step, you're going one level down. So that's what the path is. Start at 5, you either going to 4 or you're going to 8. Doesn't matter which one really, as long as you're going one level down, that's like the next step on the path. So there's no like sideways or up and down in this case for this particular question. And anytime you see that, it could be ambiguous if you're not familiar with those concepts. But what they mean by that is really just going to the next level and having another node. And there's different ways to traverse a tree. Like you can do it what they call level order traversal, which is start at 5, you go to 4, and then you go to 8. And then 4 and 8 are on the same level. After that, you go to 11, 3, 13, and 4. Those are all on the same level. And then 7, 2, and 1, those are on the same level. That's like a BFS or level order traversal. That's not relevant to this question, but I just want to point that out. We're focusing on how do you get one path from top to bottom without going sideways. So yeah, first thing that comes to mind is whenever you look at a tree question, I think about how am I going to traverse this tree? Because there's a lot of predefined ways to traverse trees. And we kind of gave some few hints in the chat for this event, but DFS to me is very clear how it applies here because DFS is literally all about going from one level to the next, to the next, to the next, until you get to the end. It's called DFS stands for depth first search, and the idea is that from top to bottom is the depth of the tree, as opposed to the breadth, which is left to right, which is breadth first search. So if we're going to go from the top to the bottom, through the depth of the tree, we're gonna benefit from a depth first search. So thinking about how do you want to do that? There's different ways to do a depth first search. There's like recursive is I feel like the easiest way to do it because you just rely on the normal recursion and the stack frames being added and so on. And then whenever you return from the recursive function, the one that called it gets continues and so on. The other way to do it is iteratively, which is like with a for loop and you have your own stack or like an array which you use to mimic recursion. We're just going to focus on the recursive approach right now. And then maybe as a follow-up, we have people post the iterative version and things like that. So looking at this, another thing I kind of think about when I look at a question is, can I use the function that they gave me by itself, or do I need to create like different functions? And and a lot of times it's not even like you could do it with just one function, but it's not worth the effort to try to figure out how to do that a lot of times because it just takes a lot of time, you might make mistakes, and it's not important to getting the solution. So what I usually do is just like first pass, literally just create this underscore version of the function, even though it's not the best code quality. Get the job done for now. And a lot of the details are going to be within the implementation. The naming definitely matters on interviews, but as a convention, either people do like helper or things like that. I just like to do underscore to like make this this is like a Python thing, like it's considered private function that you wouldn't call from the outside. So looking at the constraints of the problem, it says that we're gonna have nodes in the tree either 0 or 5,000. Well, 0 to 5,000. But the values could be negative 1,000 to 1,000 for the value, and the sum could be the same. The fact that it could be 0 is important to know because there could be an edge case where there's no node. So what do you do? And in this case, they're not very explicit about that, but they do provide an example. So in the third example, where it says root equals empty array, this is basically saying that there's no tree. And it should come out to be false because the tree is empty, there's no root to leaf paths. So this is like, I feel like this should really have been in the beginning where it tells you about, what it means. But either way, on an interview, it's your job to be able to ask the interviewer these questions that come to mind, and then they'll kind of answer. They might intentionally leave that detail out just to see if you're the type of person to ask questions and pull those details out, because that's another kind of signal they're looking for. Which kind of feels like mind games, but that's the way it goes. And let's just check. It's only good practice to look at all the examples. I was about to jump in, but let's look at example number 2. So example number 2, target sum is 5, and the output is false because going from 1 to 2 or 1 to 3, you're not going to get 5. So that's why it's pretty clear how this is false. And in that first example, they highlighted the path. You go from 5, 4 to 11 to 2. That all sums up to 22, which is the target sum. And the output is going to be true because the goal is to return true if there's a path. You don't need to return a path. You don't need to do anything else besides return true. So that's how this works. So as I try to think about how I solve the problem, I realized that I always think about how many, do I need to look at all the nodes? Like that's one question that comes up because one important factor is time complexity. Time complexity is, what is the average time it's going to take to get this algorithm done with generic inputs. So it's not an exact measure, it's really an approximation to say how things are going to scale. But that's one of the things. A lot of people unmuted. 1 second. All right. So I like to think about, that's like one question I always ask, like, do I need to touch all the nodes? Do I need to traverse or visit all the nodes? And just off the top of my head, I'm thinking yes, because if you want to know if there's a path that sums up to a specific number, you got to look at all the numbers. Otherwise, there's no way. Like if you go from 5, if you start with 5, you can't know there's a path without looking at 4, 11, and 2. So, and sometimes based on the question, you could do things without looking at all the nodes and like figure out how to arrange them and so on. But in this case, I felt you have to look at all the nodes. So to me, the best I could do is like O of n for the space or for the time, because if I have to visit all the nodes to get the solution, then that's the case. Now, if I do find it within the first pass, it's still considered O of n because that was just one input. Like this input said, I want to find 22 for this tree. Happened to find the first time. That doesn't mean it's like, much faster than O of n. It could have been a case where it would have been like 5, 8, 13, so it's like looking for 17. If that was the case, it would have been waiting until the last traversal. So that's why I can think about it. Okay, we have an O of n solution. So any solution I'm thinking about that's either ON or less should be acceptable. I don't have to worry about trying to make it more optimal. Not even that. I shouldn't say O less. Anything that's O of n, it should be acceptable. I don't really have to focus too much on trying to make it more optimized, at least at this stage. Maybe when I finish it, or when I chat with the interviewer, try to get some hints, I can go from there. But on the onset, I'm thinking about, okay, this is going to be something that I have to touch every node. So I'm okay with that. I'm going to figure out how to do that. The next thing I'm thinking about is how am I going to keep track of like what the sum is? And that goes back to the other point I was saying, where can I use the existing function or do I need to add another function? And because I need this current sum, like this running sum that's going as you go to each node, I'm just going to go ahead and default to using another function and having a space for that. And later on, if necessary, or if it's easy, I could optimize it to use one function, but that doesn't really matter at all. That would just be to show you. So basically, the idea is that we start here, you get the root node, and then you hand it off to another function that contains something you need to kind of keep track of the sums, like current sum. And what I'm doing is, it might seem kind of confusing or like I'm jumping to things, but this is bottoms up thinking. So I'm imagining, like, what do I need to have in place for the solution to work? So I'm thinking, okay, if I use DFS, as I mentioned before, it's easier to do it like recursively. So I'm gonna need a function I'm gonna call recursively. So this is that function. I'm gonna call have to have some multiple times on each node recursively to kind of get that solution. And to pass in the running sum, there has to be there's gonna be part of like there's a few ways to do it, but easiest way is just put it in the argument list. So that's why I have it set up there. Without having to go through the steps of saying, oh, how am I gonna do this? Or I might need this. It's just kind of automatic now that I'm thinking from bottoms up. And yeah, like this is they're just realizing like what are the different possible ways to pass this information from iteration to iteration. So now that's in place, another form of bottom up is like you kind of write the code as if it's done. So like I would say return has path sum and then call it with the arguments that I get from here. And then the current sum is going to be 0 because we just beginning. So even though this is not implemented yet, I'm just returning it because I know just I'm expecting this to find the answer and return the Boolean value, whether it's true or false. So from this function, that's all I need to do. I don't need to think about it anymore. I just move on to the next function. So now that we're in the next function, we got the root node. Let me call this node. So like there's different ways to go about it. I'm gonna call it a node just to make it a little bit less confusing. Node is just like any node in the tree. And as you go through this reversal, this is going to be different nodes. One thing I like to do is keep notes. So like node and like current sum. I'm going to track the value of these things as it goes along, like as I'm thinking about how I'm going to do the DFS and solve the problem. So, and this is a good step to do because rather than kind of jumping into the code, you need to think about how you're going to solve it first, what the algorithm is. And then once you figure that out, then you implement the algorithm. You don't really kind of try to code and figure it out at the same time. That's like a recipe for disaster. A lot of people do it that way, and it ends up working, but you can get tricked up a lot doing that. So you should definitely try to take a step back, figure out what your plan of attack is, what your algorithm is going to be, and then implement it. This was just something I did as like it was like a function signature. It's not really like implementing things. It's like something that you probably will have to have anyway, just at the onset from the mental framework. So yeah, going through this, I'm looking at it, we're gonna do a DFS, so we could just run through some example DFS. So going from 5 to 4 to 11 to 7, in this example, obviously that's not gonna get us 22, so that wouldn't work. And then going from 11 to 2, we'll find it, and then we need to find someone to return it. So like this is actually, like I said before, if you know the concept of DFS and trees, is very basic. So there's not too much planning that needs to happen because the algorithms are pretty much predefined, and there's not much there's not much change we're doing to it. So right off the bat, we know we're doing a DFS because we're going from the top to the bottom, and that's the depth first. So I already know that this thing right here is going to be a DFS. Now within that DFS, I need to keep track of the sum. So let's say I'm at this 5. I want to be able to do something like imagine this is just one node, right? Try to see if it's a leaf, and then if it's equal to the target sum, return true. Or another way to think about it is when recursive functions, there's always this base case, this concept of a base case. And at the very top of the recursive function, you say, what is the thing that's going to happen at the end? Like, remember, this is like bottoms up. At the end of the entire algorithm, what's the thing that you need to check for? In this case, we need to check to see if the node's a leaf node, because if the node's a leaf node, that's the point at which we're going to check to see if target sum is equal to the current sum. And if that's not clear, I'm going to go over it a few times and kind of show you direct examples. So in the very beginning, I know that for a fact that I need to know if this is a leaf node before I do this comparison. So I'm going to say if this node, I'm going to make a function actually, like just to make it cleaner, is leaf node, and then taking a node, and then return true or false depending on where it's not. We know it's a node if the node dot left doesn't exist, and the node that right doesn't exist, and we know this is a leaf node. So I'm going to use that. So if it's leaf node of the node that we got, now we want to just check to see if the target sum is equal to the current sum. Right. So at this stage, it doesn't require too much thinking. Like at this point, it's really just relying on the patterns and stuff like that I've had in the past, where it's a tree problem. Trees really do well with recursion, especially if we're using DFS. bottoms up thinking approach is typically useful. It doesn't always work out. It's like an exploration. I don't know for a fact that this is going to work out, but this is the direction I'm going into because of the experience that I have working with these types of problems. So again, more of the patterns. I have this recursive function for the DFS. I know that we should have a base case because as we go and recursively call this function, we need to stop at some point. Otherwise, it's going to be an infinite loop. So the point at which we stop is if it's a leaf node. And what we need to do if it's a leaf node is check to see if that target sum is equal to the current sum. And what I should be doing is returning this. So yeah, so basically this base case is going to stop that recursive function so it doesn't become an infinite loop, and it's going to return the answer that we need. Now there's a little bit more thinking involved. Now I need to think about, okay, when do I actually calculate this current sum and pass it along? And if we're going to do a recursive call and go into the child like 5 going from 5 to 4 needs to know that it came from 5 so that it can add it up. So because of that, what I'm thinking is that I need to first add the current the current node's value to current sum before I do that recursive call to go to the next child. And that's not always the case with trees problems, but this is the point where like you're thinking about like what is the specific implementation you're doing within this standard DFS. So right now current sum is 0 at the onset. If this is not a leaf node, which let's look at this tree on the left side as an example. We enter this half pass sum and we have 5. That's like the root node right now, the node 5. And it's not a leaf node because it has 4 and has an 8, it has children, so it's not a leaf. So what we want to do, we want to add 5 to the current sum. And that would be basically saying know that value. And then we want to say, okay, we need to check the next step in this path. And the way we do that is we recursively call the same function, pass in the nodes left in this case. It could be right, it could be left, it doesn't matter because we're gonna check both sides. But let's start off with the left. Just as a, this is actually an easier example because it is to the left. So this time we're gonna call the same function, this time with the 4, same target sum, that never changes. And our current sum is different because we had added the 5 to it, or whatever the node value was. So I just want to stop right here and ask, does anybody have any questions or feel lost or need some kind of like explanation on some parts?
I just want to do like a quick overview of what you're doing. So right now you have a helper function that basically keeps track of the current sum, and you're starting your traversal of the tree, correct? That's what we're
Correct,
doing
yep.
right now?
Exactly.
Okay.
We talked about them. We entered the problem. We call this helper function,
Baby,
passing the root,
sit down.
starting
Mommy
at
cannot
0.
hear.
Starting at 0. We try to see if this is a leaf node as a base case to know when to stop. If it's not, that means we keep going. If we keep going, that means that we need to pass along the value to the next tree node. So we're going to add that to the current sum and then do that recursive call. So now that we did this recursive call, this is where like you start to see things happening. We go back to the top. Now node is going to be 4 because that's the left of 5. And then now we try to see if it's a leaf node. It's not a leaf node. It doesn't have 2 children, but it has 1 child, which is 11. So it's not a leaf node. So we move on to the next lines, and now current sum is going to be adding the value of 4. So now it's like we get 9 out of this. And like think about this list I have up top, these notes I have, as tracking the the values for each function call. So like this first one was a function call that I started with. This is the second one. Okay, so we add the value and then now we do it again. We just say has path sum node dot left. In this case, left of 4 is 11. So now we're at node 11. Same target sum, but this time the current sum is 9. 11 is not a leaf node, so we keep going. We add the sum, we add the value to the sum, and then we do another search. We do another search again, and now we end up with 7. And because we were at 11 before, when we did this, it had became 20. So when we call this again, it's going to be passing node 7, target sum 22, current sum is 20. And this time, the thing is a leaf node. Right now, 7 is a leaf node. And this exposes a bug, or something that basically like an issue that we have, because we're checking to see if the target sum is equal to the current sum, but we added the thing after this check. So it's not going to work because it's going to be missing what it needs. It's going to be missing the entire path. So after realizing that, I realized this should actually go above, because if you don't add it to it, this check is not going to work out. Everything else should stay the same. Let's see. So now we know that this is going to be 27, and obviously 27 is not equal to 22, so it's not going to work. And now here's where it could get tricky for people who aren't familiar with working with like recursive functions.
Sorry, I
But we're
thought
going to try to walk through it.
I thought the base case for like that recursive function would have been if it's not like a node, then we could return false, so we can get out of the function at that point. Then we
That's a
can
good
like
comment. Sorry.
like
See,
that's what I was thinking the base would have been if it's not a node.
Gotcha. So yeah, so base cases, there's actually could be more than one base case. It's any time where you're not going to continue that recursion. And that is another case because we could easily get this function called the first time with empty node. Like this thing right here that's being passed the first time, it could be empty. So what we want to do is, if that happened, that this would cause an error, note that value. And that's probably what you noticed. That may be why you mentioned it. So a good thing to do would be say if node is none, then return false. And that way you wouldn't get this issue where you're trying to access value from a node that doesn't exist.
She said her favorite singer is coming. And she wants to go see her favorite singer perform.
How are people coming off of mute? I don't understand. Anyways, all right, so where were we? All right, so 27. So we're at this page. Let me kind of walk back so we don't forget. So we were at 11, but we just got to 7, note 7 and 27 because we had moved this up so we have the actual values calculated before we do the check. Now that we're doing the check, we see that, hey, 7 is not actually, 27 is not equal to 22. So this is gonna return false. What happens when it returns? For people who are familiar with recursive functions, it's just gonna go back to the original function call. So now we're gonna be back at node 11. Does anybody find that part confusing? Just want to double check. It's like the fact that we returned from this most recent recursive call and now we're back at node 11. Does anybody find that confusing?
Yeah, I'm finding that confusing.
Okay. Are you familiar with how recursive functions work? Because sometimes it could be confusing just because we're introducing other concepts and it may not be clear, but you may actually have other foundational information about it. Are you familiar with how recursive functions work?
Yes, I think I'm familiar with it. Maybe not in Python,
Okay.
but in JavaScript, because usually I code in JavaScript.
Gotcha. So yeah, whenever you call a function,
works.
gotcha. So whenever you return from a recursive function, it returns back to who called it. So like, for example, within this has path sum function, I called this self_that_has path sum, right? And this one is not recursive because these are two separate functions. So if I just called it and I just return like, return true, then it will go back. After entering this function, return is going to go back to this function, right? Anytime you call a function and then that function returns, it's going to go back to the original function. Is that part clear? This is the basic part, just the foundation.
Yeah, that's clear.
Okay, so now let's say within this one, you called it, going back to the original code. Within this function, we're calling the same function again. So when this returns, it's going to go back to the function that called it, which is the same function, just with different arguments.
Okay, I get it. I think I get it. So which means that the current sum will not have changed, and also like the node would not have changed. So it will be back to the previous node, right?
Exactly. So let me perfect. And let me just walk through it one more time just to tie everything together. So let's say we're at node 7. We know that it exists. We added current sum, so it's 27. We see that it is a leaf, and then we return false because 22 is not equal to 27. So now we return false. This 27 doesn't exist anymore. This 7 doesn't exist because we return to who called it, and who called it was node 11. So now we're back at node 11. where the current sum is still 20. And like we said, it's still the previous one, so you got it right. So now that we're here, we realize, okay, now we gotta go to the right, right? Because we've been checking the left the whole time. We're at line 30, like we're at line 30 with node 11. We passed node 11's left child, which is node 7, and it just returned false. One thing I forgot to do is return here. So like this would return false, and it only checks one path. So we need to check the right side. And this is another thing where it's just part of basic DFS concepts. That's why I didn't go over it too much. I can send some resources from it. But in DFS, you gotta check the left child for binary trees where there's 2 children, the left child and the right child. So right now we've only walked through going to the left child. We need to check the right child. And at this point in time, we're at number 11. The right child is actually gonna give us the answer. So it'll be kind of more clear as we walk through it. But what I want to return is the result of whether or not this target sum is equal to the current sum. So I'm just going to say, okay, now that we're not just doing this, we need some way to like combine those things. It's going to use like a simple or statement and say, if the node that right gets passed in and it returns true or false, then we get the answer there. Okay, so now we're checking the right side. It's going to go from 11 to 2 instead. And now from the top, we know 2 exists. We're going to add 2 to the current sum. So it's going to be 22. And then 2 is a leaf node because it doesn't have the left, it doesn't have the right. And 22 is equal to 22. So that's going to return true, which is what we're looking for. So when this returns true, just like we explained before, it's going to go back to the previous call, which was 11. And now 11 is going to say, it's going to be on line 31 because 11 had called has path sum with its right child, which was 2. And now return true. So now 11 is going to return true because this whole statement, this or statement, the left side when it was 7, that was false because it was like 27, which is not 22. The right side, which was 2, that was true because 22 was 22. So false or true is equal to true. And this is like this returned back up to whoever called node 11. So when this returns, now we delete 11, delete 20, now we're back at 4. So now that we're at 4, 4 had called, if you remember, 4 only called his left side, so it didn't even get to this yet. But because 11 returned true, it doesn't even go to that because that's how OR statements work. If the left side is true, it doesn't even go to the next side. That's not too important for the details of this, but just to explain how this particular implementation works.
Question.
We just keep going up the stack until we get back to the root. So now that we're at 4, 4 is going to return true based on the left returning true. And now we're going to go back to 5. And now that we're back at 5, that very first call, which had called left to get to 4, that's also going to return true. And then now we get there was no caller before this one. There's no more recursive calls. It's going to go back to the original caller, which is has path sum without the underscore. And then this thing itself is going to return true. So now that gets to return true, which is the solution. Well, whatever is checking the solution is going to use that to see if it's right. Look, I got a question from Issa.
Yes, I want to know if we could turn I guess self has path, checking the left and the right into variables like left equals self private has path sum and then right equals self has path sum. Like I don't know.
So we could do that, but there's one problem. Let's see if you can figure out what that problem would be. So left equals this, and we'd be like left result, and then right result equals this, and then move this forward. So is there anything like, can you like notice if there's any issue with this one compared to how it was before? And let me put it in comments maybe. Anybody, not just
Increases carbon density.
So it doesn't actually, because of the way time complexity works, where, in some cases you might find it right away, some cases you might find it right there at the very end. It's all like an average across the entire potential of the inputs. So time complexity still stays the same because no matter what, you only hit at most every single node. But you're still like you're correct in the fact that it increases the time it takes. It's just that it wouldn't increase the time complexity, it'll still be O of n. But it also means that you're gonna go through each of the left and each of the right, no matter what, even if you did find it. Because this OR right here is making it so that you actually need to go to the right side if you find it on the left side.
Okay.
And so this is still a valid solution and it's still O of n time complexity. It's just that this one's a little bit more optimal because it doesn't waste time checking every single path before it finds the answer, because it doesn't need to explore all the left and the rights.
Yeah, please, I'd like to ask.
Yep.
How does you saying check the left node or the right node? I don't entirely understand what happens there. Does it like do the first one first? So if it's true, it will not do the second one, or how does it work with the all this?
Gotcha. So yeah, basically, let me see if there's a way to do it. Yeah. So because this is returning a Boolean right here, has path sum, is either going to return true or false based on whether the target sum is equal to the current sum, or if it's like it's this other base case where there's none, it's going to return true or false. So if it returns true, in regular OR statements, if the left side is true, it doesn't go to the right side because it doesn't. Yeah, like sometimes I'm pretty sure you already know the concept, but seeing it mixed with these other stuff makes it hard to grasp. Just like recursion with Stacy, like that's the type of thing where it's like all this overhead makes it harder to grasp those other concepts. But like if you really hone into it, you just start to get it. This is really just using regular Boolean logic.
Oh, I get it now. Thank you.
No problem.
Hey, Esco, I have a question.
Yeah.
And looking at a problem like this, if you had the choice between recursion and iteratively doing this, did you always lean towards recursion? And sorry if you already answered this previously.
Oh yeah, I looked at that yesterday. Yeah, I always lean toward recursion because it's way easier to me to be able to implement it. If you did this with like iteratively, you got to create your own stack. It's not that hard. It's like you just got to create your own stack and then manage it that way. Like instead of doing a function call, you would add the next node to that stack, and then in that for loop, you pull it from that stack and so on. And it's
Would
just
you
like
say
doing it
that?
recursively.
Oh,
Yeah.
sorry, keep going. I was just
Oh,
gonna say,
yeah, I was
would
gonna
you
say-
say that the interviewers would, like to see you
Yeah,
do
from my
recursively
experience-
versus iteratively?
Yeah, from my experience, they don't care at all. It's very rare to see anybody do it like iteratively, and it's like it's not really something that matters as much to the goal, the problem we're trying to solve. They may try to do that if they're trying to get some more insights. They say, okay, now how you do it iteratively? They can try to ask you that if you finish a question really fast, and they want to try to get more insights, or whatever the reason is, they can try to do that. But it's more like an additional thing that I don't think is as like it's not something to worry about as much. I wouldn't say personally, because at the end of the day, you're still using the same amount of space. If you're doing well, not the same amount, but roughly speaking, if you have to create another array to mimic the stack that happens when you make a function call, you're still using more space. So you're not saving much or anything really by doing it iteratively. You're just doing it in a different way.
Yeah, I think. Oh, sorry. I was just gonna say an iterative approach. It kind of doesn't it. It would leave the opportunity to have more errors, like if you had like a null pointer exception or something like that. Don't you think? I feel like doing it recursively is better because there's only really one way to get it right. And if you did it iteratively, you could introduce more edge conditions by let's say if you were to if you try to pop off the stack and you had no more you had nothing else left in the stack or something like that, or it just allows you to make more errors, I would believe.
Yeah, I feel like it's more complicated because you got to mimic the stuff that's happening by itself.
What? Writing recursion.
And it's not.
Are you good
it's
with
not,
writing recursion? Solving graph problems with
I think I'm probably telling somebody else. So yeah, like I feel like because we don't do it often, like, and there's no like with recursion, like I mentioned, with the base case and bottoms up thinking, that's a framework that already exists that makes it easier to reason about and like without thinking too much. But if you do it the other way, iteratively, maybe there is some stuff like that I didn't really look into, but it's going to be harder to jumble those things like on the fly if you're not used to it. That's really the only thing. But if you
Yeah.
practice doing it iteratively and like get used to it that way, then you can avoid those issues. But personally, I prefer to do it recursively.
I've been studying algorithms for a little bit, and honestly, I tried to do it iteratively, and I've noticed the only people that do it iteratively are like people that use like lower level languages like Java, C++, and I just don't like it. I don't know. It doesn't really. I feel like this is doing it recursively is more intuitive, and since it's not a huge tree that you don't really have to worry about running out of memory. So I don't really see a advantage of doing it iteratively, in my opinion.
Yeah, same. And there's different problems where it makes sense. Like the very simple example is like Fibonacci, where if you do it recursively, like there's less opportunity to optimize it than if you do it iteratively. Or you got to introduce more things like a memorization and stuff like that. But if you do it iteratively, it's much simpler to get the optimal result. And so it really is dependent on the problem. I've noticed most of the tree problems recursively is just the easier way to go about it. And there's not as many ways to optimize it in the other way. But it's definitely case by case. So always look at the factors, consider all the details before you decide.
Understood. I appreciate both perspectives. Thank you.
No problem. So I think this probably should work, but what I like to do is kind of go through it and then find other examples. So let's say if we're looking for a target sum that's like 5, 8, is that 13, so 26. So if we're looking for a target sum that's 26, and let's just continue on where we left off. We were at 4 and then we went back to 5. So now that means that we went through 5, 4, 11, 7. We went back to 11 because that was the recursive call. And then we went down to 2 because we went to the right side. And then we went back up to 11 and there's no more children. So we went back up to 4 and then 5 and so on. So now let's say it continues on to like 8 and then like 13 and 4. And let's say our new target is 26. So like the first path really. So going from 5 at the top, where is that? One second, where are we at? Okay, yeah. So going from 5, if we return from 4, from our last example that we went through, now it's going to go to the right. And let's say our target was 26. So instead of being true, it returned false. So that means we're going to go to the next side, which is the right side. So we end up with node 8 being passed in to has path sum. And we get to the top, 8 exists. Current sum plus equals the value from 8. At this point, current sum, well, since we're at 5, current sum is already 5. So I forgot to put that there. Let me just put this history. All right, so that was going to be 13 because we're at 8 and doing 8 plus 5. Is it a leaf node? Let me see. 8 is not a leaf node. It has 2 children. So we're going to skip this return and it's going to say check my left. So now it's checking the left of 8. Now that is 13. So node 13 is being passed. And get to the top, node 13 exists. We add the current sum to the value, it's 26. And then we check to see if it's a leaf node. Yes, it is a leaf node because there's no left, there's no right. This thing is doing its job. And then that means we check to see the target sum equals current sum and we return it. And in this case, 26 equals 26. So it's going to return true and go back to the parent, which is 8. So now we're going to go back to node number 8. And node number 8 just had called has path sum with its right child, and it just returned true. So now we're at the end of this function for node 8. It's going to return back to 5. So now return back to 5. And now 5 had just called its right side. 5 already called the right side, so it's going to return true. And that's going to be the answer. It's going to go up to has path sum and then return true to the solution checker, and that's going to get true. So one thing that is more about DFS, and maybe there'll be like a separate session on DFS. But one thing you probably notice is how it always goes to the left. Like if you start with 5, like from the very beginning, we went 5, 4, 11, 7. Like it kept going to the left, and it only went to the right after it came back up from the left. And that's just this the way that we're going to So we're checking ourselves, we're checking the left and the right. So this is like called a pre-order traversal, I believe, where you're checking your own value, and then you go to the left and then go to the right. And I think it's probably worth dedicating like a different session to talk about DFS itself. For anybody who has questions around that, this is more around like being able to utilize DFS to solve this problem. Any
have
questions
more
on this so
recursion
far before I
also?
check? Yeah, say it one more time.
Could we have more recursion examples also? In the
Yeah,
future?
that's
That'd be
a
great.
good one because DFS relies on that as well. So maybe kind of do like a base introduction to the recurring part, and then maybe even 2 sessions. I'll figure it out. Maybe some other people are willing to help me with that. Before we try to win this solution, anybody want to have any comments or questions, or want to go over anything else again?
So for just a overview of how this works is we're starting at the root node. We're doing, we're traversing the tree all the way until we get to a node that has, that's a leaf essentially. While we're keeping track of the value in each node, and then since we're doing it recursively, if we reach the end and it's not equal to the target, we're going to pop backwards in the tree to the previous node, then go down the if it's the left path, we'll go down the right path. If it's the right path, we'll go down the left path. And then
So
we'll
that part, let's stop
continue.
that part. Wait, let's stop that part.
Oh, no.
So you said if it's the right path, we go down to the left path. So in this case, that won't be the case because, well, maybe, yeah, it depends. So the way I can see it is that if you came from the left path, yeah, oh yeah, I get what you're saying now because you're the parent.
Yeah,
But
I think
basically,
I
by
worded it.
default, gotcha, yeah. I just want to make sure there wasn't a misunderstanding. By default, we're always going to the left. And then if the left is exhausted, then it goes to the right.
Okay, yes.
But
Okay,
not
so
the
The right
then,
exists.
because if you went to the right, that means you already went to the left. So there's no from right to left, always in this case. And that's because of the order of these statements. If I reverse the statements,
okay.
it would check right first and move to the left, and it would still work. It was
So
just
we
the order
always
of the way
traverse from left to right, essentially. That's what you're saying. Like we're always going to
only the way
check the
that I
left
coded it.
first.
Yeah, not
Well,
always though. Only because of
and
this specific implementation.
yeah, okay,
Gotcha.
okay, I see. And basically, you're popping back upwards the stack whenever you reach, because you're using recursion. It's going to be using a stack underneath the hood to keep track of the frames of each each level. So whenever you're so whenever you reach a leaf node, which is a node that has no children, you're gonna check if you haven't reached your target, you're gonna pop back upward and then try the other path until you eventually reach the sum, and now you have the path that is your I guess your target that reaches the target sum, right?
Yep. All right, let's see if it works.
Yeah, I was going to ask, do we stop when we find that there is a sum of the target sum, or do we keep going through to see if there are multiple targets?
So good question. So when we find the target sum, this is considered one of the base cases because, oh, sorry, when we find a leaf node, it's considered the base case because we don't need to do any future recursive calls. So that's like where you're supposed to stop. And within this base case is where we do that check for the target sum and we use a return. So this is basically saying that anytime we hit the leaf node, anytime we're checking for the target sum, we're stopping that recursive calls. When we're stopping that traversal, at least at that for that path, and then we're kind of going back up. Let's say this is false, right? Let's say this is false. We don't fully stop because sorry, let's say if it's true, that means that every single time we return, it's gonna keep returning, right? So when we were at 2, we went back to 11. 11 just returned true. Then go to 4, 11 return true. Go to 5, 5 return true. Because on the left side is this or statement, true is gonna mean that you just keep going, you don't check the other side. But if at any point it returned false, let's say like it did with 7, 7 was like 27, which didn't equal 22. It returned false here, which means that now we can check the other side is 4 because it's evaluating the false. And that's when we check and we continue to go down from 11 to 2, and we're still doing the check. Does that answer your question?
Yes, it does.
Cool.
I have a quick
Um,
question. I think for the most part this makes a lot of sense. I think what would really confuse me if I was presented this in an interview is the input. Like, do you normally receive this input as an array of like numbers and null values? And how do you like derive like the tree like structure from these numbers and null values?
Gotcha. So this is a way. So there's like interview questions called serialized binary tree, and what that means is like if you have a binary tree like this, how do you get it stored in like a file or a database where you can kind of reconstruct it and get it back? And the format for that, I forgot exactly how it works, but basically, if you look at this array, 5 is a root, then 4 and 8 is the children that of 5, and then 11 is like the root, like its uh own subtree, and the children 7 and 2 is here. There's like a formula that means like I forgot exactly what the formula was, but there's a way to construct an array based on the values in the binary tree to go back and forth between the tree and an array. And the reason why it's like this is because that's how they pass the test cases. So like they pass it as an array to run
Yeah.
against your code. But when you actually get it in the code, you don't get it like that. You get it as the root. You just get the actual tree node, which is what you have to work with. So it's
Okay.
actually confusing. The fact that they put it, they really shouldn't. I don't think they should be putting this. It doesn't make sense. Like it doesn't have any value. They're just showing us the internals, so they don't really need to.
So you have to have some context around like how that actually is constructed.
Yeah, so like exactly. There's a standard formula. I forgot what it was, but basically, it's like 2n. I forgot exactly what it was. But you applied you based on the position in the tree. You
Two times
you map it
plus
to an
one.
index in the array.
Two
What was
times I
that?
plus one for the left. Two times I plus two for the right.
Nice. Yeah, if
Yeah,
you could
I
put that
is
in the chat.
in.
Yeah, if you could put that in the chat, I think that can help some people. But yeah,
Okay.
basically, it's like you're mapping the position in the tree to a position in the array, basically, in a consistent way that allows you to rebuild it and serialize it, like deserialize it and serialize it. Okay, so yeah, so if you look at any node, you're saying that the left node is going to be 2 times, is the 1 supposed to be the index?
Sorry, that should be an I.
Okay,
Yeah, I
gotcha.
is index. My bad.
No problem. All right, so these basic test cases just passed, but when you run the full thing, it's going to hit more and more sample problems, and there could be edge cases that don't get reached. So I'm going to press submit. All right, cool. Still works. One thing I want to show before we head out, actually, is there any other questions?
Yep, I would like to ask one question. I
Yep.
know it's quite basic, but I'm very confused. So when we return back, after we've checked everything in the left and we are back to the roots, right?
Mhm.
How does the function know to now move to the right entire? How does it not go back to the left again? How does it know to, okay, fine, now it's the turn for the right part, like 8 and
Got it. So one of the things that is a misunderstanding that you have, it doesn't actually go back to the roots when it finishes. So when it goes to 7, it goes back to 11, and then 11 goes to 2. So it doesn't go all the way up to the root first. And that's actually, it's like the way that's implemented. So if we say that, imagine we're back at node 11, right? We're at node 11. We called this whole function with node 7. 7 is a leaf, and the target sum was not equal to 22, so it returned false. So now that it returned false, we go back up to 11 because that recursive call finished. The stack frame is now not being used. It went back to the function call that had 11 in it. Now it's going to continue executing from where it left off. So it's going to say or, and then it's going to go to know that right instead. And that's how it has a chance to go to the right side. Whenever the left side returns false, then it goes to the right side.
Oh, I see. That makes so much sense. That makes it so clear. Okay.
No problem. And we're also gonna have a like another session like DFS, which is like kind of going to go through this more explicitly, like talk about how it works.
Okay.
Cool.
I have a quick question.
Yep.
Where will the recording be posted? Will it be in Discord or the Facebook group?
Sorry, it's hard to hear. The audio quality is not good. Can you say that again?
Will this be posted in Discord or the Facebook group?
Okay, yeah, it'll be posted in the Facebook group. Yeah, we don't really have a channel for sharing the recordings, but I could think of something and maybe somebody could help out. I know Peyton's helping to manage the Discord. Maybe I can reach out to him to help to figure out a plan for that.
I also had another question.
Yep.
So when you're updating your current sum before checking for the base case, could this cause a problem in cases where, say, for the condition for a leaf node might be different and that sum needs to change? So instead of updating current sum before like a base case situation as well as a regular path situation,
So-
you would kind of do it separately.
Trying to think of a scenario where it'd be like that, but without any specific examples, maybe it helps to kind of go through it. So like the only reason why we need to check beforehand is because if we did this comparison without that, it would be out of date. Like it would be missing that number. That's really the only reason why. So I'm trying to think about scenarios where we wouldn't need that. I guess it would be like a different type of question.
Like I guess with this specific question, if you were to update current sum in the base case as well as outside of the base case, would that,
Oh, you mean like within this if statement?
yeah,
So yeah, the only problem with that is then that means that current val will be the same. It will stay at 0 until we hit a leaf node.
and then also update it outside of, because with the base case here, you're always returning out of the function anyways. So before you make the second call, update current sum.
So before this call me? Gotcha. So yeah, that could work, but the problem I see is that it has redundant additions. So like this is more optimal because what we're saying here is that we want to update current sum if there's a leaf node and also if it's not a leaf node. So if we want to do that in both situations, we're better off just doing it at the top since we already know we always want to do it regardless.
Okay.
And then one idea I had for like, if you remember before I was talking about the first step, not the first step, like one of the few things I think about is do we need another function to like pass more parameters into, and how it's not usually worth it to try to figure out how to stuff them into the same one. In this case, figured out like a simple way to do it just by modifying this one. So the problem that I had before that required another function is that I needed to keep track of current sum. But in some problems in the past before, I've taken an approach where instead of like adding it, I subtract and I check to see if it gets to 0. So that gave me an idea. Okay, maybe that applies to here. So instead of saying, go from each node to each node and adding the number to see if it equals target sum, I can say take target sum and subtract the number of the nodes until we get to 0. And that should work the same. So what that would mean is that I would take, I wouldn't use this function, right? And then instead of adding it, and I wouldn't even need to use current sum. I would just do like target sum subtracted from the value of the node. So imagine you have 5, right? You have the root, you have 5. You have just check to see if it's null. If it is null, none, you return false. If not, you say take target sum and subtract 5 from it. It's like 21. And then the same other logic really applies. So you still need to check all the children. It's just that whenever you get to each child, you're subtracting the value of it instead of the actual, instead of adding it. So like, let me do 2, 4, 11, 10. Oh, no, right. I started with 26. So anyway, but without going through those details, just walking through the code. If you're subtracting it each time, instead of adding it to the same number, you're just going to end up with 0. So the check I need to do when I get to a leaf node is does target sum equal 0? And then everything else should work the same. Unless it's typos. If node, okay, so it's root. So in this case, because I'm using the same original function, I gotta just use root everywhere, which is still valid because as I was saying, each node has its own subtree. So this is the legitimate root of that subtree. And when you call recursively, the only view it has is that root. So it makes sense. And let's see, am I missing anything else? No, okay, that's another one. Keep doing it. Now that I'm checking, there's probably none left. Okay. That's perhaps.
You still have current sum in the code.
Oh, okay, nice. And yeah, all the mechanics should still work out. Like it needs to go from the top to the bottom through a path. It needs to check the target sum when it's a leaf node, and it needs to, in this case, subtracting it has to make it 0 if it was equal. Because like if you subtract all the values that add up to the same value, you're gonna get 0. So this whole thing should just work as is.
What would be like a real
Okay,
world?
now one.
What would be like a
the
use
original
case of
function.
this?
So use case of this in other questions, it is useful to be able to think about it as, yeah, so it works. In other questions, it's useful to think about it as subtracting instead of adding. I can't remember the exact context or details, but I know for a fact a few times when I had thought about it that way, it made it a lot easier to implement it. And this is like, if you look at this thing, this is actually more concise. But again, I stress to not focus too much on getting it like this because you're not gonna pass more. You know, you're gonna probably just end up fumbling and like messing up the solution, trying to figure out how to stuff it into one function. I just wanted to show you this because there's another perspective for other problems where it actually might be useful. But it's generally not necessary to do it like this.
Okay. Hey, Esco, can you hear me?
Yep.
Okay, great. So thanks for taking this session. I appreciate it. So the question I asked was, how would you go about debugging and troubleshooting errors if you have failed test cases in your submission? And would the interviewer ever ask you to provide test evidence? Basically, so suppose you got stuck on some, edge case or something like that. How would you go about, debugging this?
Gotcha. And what was that last question you had?
Oh, would they ever ask you to provide like test evidence or test cases in absence of like a script like this?
Gotcha. Yeah, like most all the interviews I've done, we don't provide any like for Airbnb and for Uber, we don't provide a list of like test cases. We just ask the person to create test cases because that's another test that we're doing to see if they know how to test code. And then we just make sure they're not missing any edge cases. And if they are, we just say, hey, what about this thing? And then just add it. So that was the last question. And the first one, the way I would go about it is basically like the way I do in normal code, where ideally I would use a debugger. I've used a debugger on interviews many times before, but that's only useful when you have your own machine and you have that control, right? If you're doing it from like an online system like this, or like HackerRank or something like that, where debugging isn't a feature, that's like a disadvantage. But it would just be kind of going through it step by step, like even as far as like doing console like print statements, because that's not the ideal way to do it. But if you don't have access to a debugger, that's really all you gotta do. Sometimes I know one other person who I was interviewing, they asked if they could share the screen and they copy and pasted it into an IDE and then they bugged it from there. I would suggest doing something like that too. I think that's very useful. But yeah, it's really no different from how you would debug your own regular code. I would say make sure you not make it like some people try to rush through it. That's a problem when they feel this anxiety or when they feel they run out of time.
Yeah.
But that may be worse if you rush through it because you're not going to catch the thing and you're not going to get the fix in the time. So it's better to just kind of treat it like a debugging your own regular code.
That answers my question. Thank you.
No problem.
Okay, so in an interview setting, how much time? I've heard that's like usually 10 to 15 minutes you would give for like a question like this.
So it really depends. For most places, it's going to be 45 minutes, maybe even 50 minutes because they actually leave time for questions at the end. So you will get an hour time, but the time you have to solve the problem is like 45 minutes to 50 minutes. And in some cases, like with Facebook, where they like to ask 2 questions or like multiple questions, that's when you would get through like 10, 15 minutes. But then it will be this type of question, like the easy type questions or the medium type questions not all mediums, like a lot of mediums take 45 minutes to do. So not all of them, but like the easier type questions, they try to throw in multiple easier type questions as opposed to one big hard question. At Facebook.
Okay.
That's what I've seen. That's what I've seen from friends I've heard.
So,
Yeah, the time limit, but generally you have a whole 45 minutes to 50 minutes for the entire round to code.
so I'm pretty new to your Facebook group. I actually just joined it like 2 days ago. I don't know how I found it. I somehow found it. I think I was on Twitter or so. I don't know how I found it. But so this is like interview prep for big tech, essentially. Like so this is I'm gonna ask this is what I'm doing right now. Currently, what I'm doing is I'm going through and I'm learning all the patterns because I know that there are patterns to each style question. So, you know, right now, this is the, you know, this is like the binary, or no, this is the depth first search pattern. You know, there's binary search and then there's all the other ones. But so my goal is to be really good at all of those and then go on to an interview. Um, so like an easy style question, this would be for like this would be like for like a first interview, you know, because they do several different interviews, right? Depending on the
Yeah, so
role.
for something like this may be like a warm up. So like if you see here at Amazon, Microsoft, Facebook, probably more, a lot more. This type of question, let me think about it a little bit. This is I have a little bit of bias because I see it marked as easy, but thinking about the type of question they get asked, the thing is, there's not too many edge cases with this one, so it may be still on the easy side. In some like definitely a few years back, this would be probably just one question, maybe like 8, 10 years ago. But like
Yeah,
nowadays, this is like a warm up type situation, or like one of two questions in the same round.
yeah, because I mean it's become kind of an arms race because before people didn't know how to do LeetCode, and now you know everybody is learning how to do LeetCode, so they have to keep making it harder.
Yep. Yeah,
So
exactly. The
that's
perception is changing, right? Something that seemed like it was hard to do before, now everybody's studying it and it seems easy. Not exactly like you said, getting harder and harder questions.
okay. So what do you recommend somebody does to get to get good enough to pass these interviews? Because I mean I'm following a program that pretty much lays out like templates, gives you an entire decision tree on how to approach these problems, and you know it's a
Nice.
lot, and I think it's going to take me like a few months, probably like 3 to 6 months to really get like super good at this. Um, but what do you recommend doing?
Yeah, I think that sounds like a good resource. If you could share that in the chat, that'd be useful. But
Oh yeah,
basically,
it
3 months sounds about right. Like
is.
if you're doing it on and off, not full time, then 3 months it sounds feasible because you only have nights and weekends, and even then it's like not full time hours on that. So like you're doing something on the side on a little bit at a time, so it's going to take time to build up that practice.
Yeah, this is a
On
paid
my side.
resource and it's like only reading, but it's called Algo Monster. Sorry, it's Algo dot Monster. I'm sorry, I don't even know. Let me just
Gotcha.
but
Yeah, I'll check that out. Oh, I'll go down
yeah,
most.
yeah, it has a lot of information on it. I mean, I like this because like talking with other people because it kind of reminds me more of when I was in college and like my data structures class. It's just easier to, you know, talk with people. But
Yeah, and be able to ask more specific questions.
yeah. But yeah, okay, so I'm just wondering because I my goal this year is just to get in because you know I've been studying this for a while and I was just like I don't know, I'm kind of I get distracted and then life comes in the way and you're doing other
Yeah.
things and I'm like I just need to actually focus on this and do it because I've and then I think that it'll work out pretty well.
Yeah, I hear you on that. That happens to me too. Just like slow starts. Somebody posted a link to an article I wrote. I'm having weird issues with Zoom chat. I'm trying to be able to send a message to everybody. Wait a minute. Okay, that's why they changed the name of the label. So yeah, somebody had recently just reposted this link. If you can see it, Elias, this is kind of where I break down how I study and prepped for my interviews that I passed. And it's kind of like a blueprint for how do you structure your own. It's not like there's some specific details as far as topics, but not as far as resources. It's more of like a framework. How do you build that plan? And to answer Jose's question, who posted it, he says, you want to know if it's still valid in DSA today? I would, especially with the advances in AI, I would say that some parts of it, like the amount of hiring that's happening is a little bit different. So like being able to push back interviews, that could be useful, but at the same time, because the headcount is smaller, the role can be taken up. So like that part kind of changed, where it's not as abundant as it was before. This could be changed. Like right now the market's recovering, like the economy, the interest rates are starting to like actually go right down and so on. So I imagine that things are gonna start picking back up at least by the end of the year to next year.
Yeah,
That's
this
just a big
is going to
concern.
be a pivotal year, it seems, because of the election.
Yeah,
That's going to
that
be a
too.
key indicator of what goes on with the market.
Yep.
Can you hear me, you guys?
I can hear you. Yep.
Esco is
Somebody said,
Chi.
oh, what's
You
up?
hear me?
Yeah, I can hear you.
It's Chi.
Hey, what's up? How's it going?
Yeah. I was just gonna say, like, yo, thank you so much for doing this class. I really appreciate what you're doing for the culture and just for tech in
No
general.
problem.
And yeah, I just really appreciate it and just keep going.
Thanks, man. Appreciate it.
Yeah, this
Appreciate
is
it. Not
very
everybody
helpful.
does it. I appreciate it. Thanks.
Yeah.
I wanted to get access to the Discord. Do you guys have a Discord link?
Yeah, let me get that link right now, actually. 1 second. I'm gonna put it in the Zoom chat. If I can find it.
Hello, Esco. I have a question on the code.
Yeah, sure.
All right, I want to ask, does the order in which you call the nodes, the recursive call, function calls, does the order matter or just you can call it anyhow?
Oh yeah, so the order doesn't matter at all. There's different ways to the only reason the order would matter is if you're trying to read out the numbers in a specific order. But no matter what, all the numbers are still gonna come out. So if I took this and I removed it, actually not, if I say right and then left instead, which is the opposite, it'll still work. Yep.
Okay,
And I submit
great.
that to check
Thank
all
you.
the cases and it should work. Yeah, it works. But yeah, all it is just instead of it being like 5, 4, 11, 7, and actually it'll be like 8. Yeah, we'll start 5, 8, and then 4, 1. Then it goes back up to 4, up to 8. Then it goes down to 13, and so on. Like it's just different order.
Okay, thank you.
No problem.
Hey, quick question. Will we be, I'm not sure if we have that much time, but will it be possible to explore a BFS approach to this problem?
Let's see. BFS for this one. Yeah, that would be time, maybe, but the problem with BFS is that you need to have additional code to track the path because the order you're going in BFS is not going to be a root to leaf path. It's going to be a level order traversal. So like you would start out with 5, and then you go to 4 and 8, and then you go to 11, 13, and 4, and then 7, 2, and 1. So if you're doing, that's what BFS would do. If you're doing it that way, you need a way to link the fact that 5, 4, 11, and so on are going to be on the same path, even between 7 and 2. It's definitely possible. Usually, like you use like a map where you kind of map the parent to the child because each child has one parent. So if you have a mapping of that, you can kind of walk through it and then get back the path. But it just takes some time, which you don't have at the moment.
Okay. So I was thinking maybe like a queue where the input, the type of the queue will be like a pair of a node and the current sum. Like you said, right? So like the sum at we're gonna have to compute the sum at each level because we're doing a level traversal, right?
Yep.
So like let's say we move from 5 to 4, we're gonna have to compute the sum of that. And then the check that you have on line 23 will do that also, right? At each order. Just gotta
Gotcha.
make, yeah.
True, yeah, that's a good point because we don't need the explicit path, we just need that sum.
Right.
So instead of what I was saying about the map, you would still need something like it though. You need a way to keep track of multiple sums at the same time. So you need to know 5 and 4 and 5 and 8 at the same time. And then 4 to 11 and basically like keeping track of different running sums for each potential path all at the same time, which still has a bit of complexity, but definitely doable.
Yep.
So you got another hands up here, Bullrun.
Yeah, I do want to say thank you for, organizing this. I think it's best if we have people to, practice with rather than just doing it alone. I have a question about the testing. So what would you recommend, like after you finish writing your code, right? And you want to, test for the interviewer, do you recommend writing more code? Like, like how you, like in the real world, you're writing your code, you write some unit tests, right? So is that the same thing you would do on the interview, or you just verbally run through the tests?
So yeah, it's an interesting question because it's kind of what's the word? I don't know, it's like not really formal. Like a lot of times, literally just simple things like saying calling, like it's all about the inputs. There's no like test logic where you're unit testing things or making mocks. It's literally saying that you have some kind of input like and this is a bit harder because it's a whole tree, but like whatever root is going to be that you're going to use, whatever target sum, and like basically you have a bunch of different example trees, right? Like example tree inputs, and then you have like a loop. You loop through them, and then it's like passing through, pass some, and seeing if it has an expected answer and then the not expected answer. Like very rudimentary, quick code that people expect doing these interviews. But other companies, like it really depends on the company and the interviewer. Other places just let you talk through it, like say, hey, there's no time left, so just tell me how would you design it at the test case. It's like you would say, hey, I have a tree with one node, or a tree with only like one line of nodes, or a full tree, like basically to describe all the different properties, all different types of trees that can kind of touch different edge cases. So yeah, it's both basically what you said, like verbally, or just writing it out, but not like an official test framework. And it's not as important. Like a lot of them don't consider it to be as important for the past interview. It's just like if you have time left. So that's why sometimes they just ask you for verbally because it shouldn't really hold up anything else.
All right, that makes sense. Thank you.
No problem. Cool.
So-
Yeah, a few more questions, and then I can jump off.
I have one question. Do you have any recommendations around what language to use? And how does language features affect you? So if there's a language feature that can do what you need to do, and you go ahead and use the language feature instead of implementing the algorithm, does that count against you? Are you judged because of that? Like, how does it work exactly?
Yeah, so it depends on what the question is asking for. So like, and you should definitely confirm with the interviewer. So like, if the question is trying to get you to implement like a custom sort algorithm, and you just use like the language's own sort or a custom comparator, then that wouldn't really be acceptable because they're not getting to see your insights into how do you use your own knowledge of data structures algorithms to solve that problem. But if the question was about something else and sorting was a small part of it, then it doesn't matter. You use the built-in sort and then continue on with the main question. So it requires direct communication with the interviewers to ask them if you can use this or are they like testing for your way how you would implement it.
Okay, thank you. And around language, do you have any recommendations?
So always use the language that you're most comfortable with because there's zero advantage using one language or the other. They just want to see the answer to the question. So they don't care about if they use it too. It's not impressive. Like people think that it will be show them that they can do the job better, but like they expect you to be able to learn any language, on the job. So they're not caring if you're coming in on the same language. They just want to know you can solve the problem. So it will hurt you if you try to choose a language that you're not really comfortable with because you can make simple mistakes. So that's why you should always use the language that you're the most comfortable with. And if you have multiple ones that you're kind of good with, then like, and if that includes Python, I would say Python is just the easiest to go with because very concise and has a lot of built-in packages, queues, heap, all that stuff is already built in. Java is similar in that way, but Java is very robust. That's why I would say I'm leaning towards more Python. If you're comfortable with Python in other languages.
Thank you. Thank you.
Cool. And we got Michael.
Hey, Esco.
Hey, how's it
Just
going?
thanks for inviting me. I was following along. I actually was following and doing it in JavaScript as you were doing it.
Nice.
Especially since I was like studying up on DFS recently, I like blogged about it and all that. So yeah, this definitely is good practice.
Glad it helped.
Absolutely. And we need more of these. We need someone said we need to probably do it daily, but I know time
Yeah,
constraints and all that. But if we could round robin it probably to do it daily, that would be good.
yeah, that'd be lit. Because I started as weekly because I wasn't sure how many people was gonna volunteer, and also the commitments. But if it could be daily, that'd be even better. You know, if we get enough volunteers. Next one is I'm not sure I pronounce your name, Sahir.
Yeah, it's yes, sir.
Okay, that makes more
Thank you
sense.
for doing this. I've been
No
following you for
problem.
a while, and I'm a computer science. I studied it at university, and I'm a mid-level software engineer right now. But every time when I come to these sessions, I find myself it's more for like a refresher course, and even though I have a job now doing software engineering, I don't have the routine of continuing with the data structures and algorithm whilst being in a job. And then when I'm considering leaving, then I have to start the engine again and then having to
Yep.
have time to refresh myself. And that's why I came into this session today. Well, my question is, do you have a routine despite being in a job? Do you just do it anyway as a daily or weekly habit every week doing data structures and the algorithm?
So that's a good question. I feel like it really at some point I found it interesting, so I kept doing it, but then I fell off because I had so many other things piling up. But I feel like the more you do it, the shorter it takes to catch up on it. Because from when I was at Uber in 2021 until when I transitioned to Airbnb, it only took me like a month, and it wasn't really even a month. It was like I was really mad busy at Uber, so I was taking like a small amount of hours per week over 4 weeks to prepare for the interview, and I was able to do well because I was already doing stuff. You know, I wasn't doing it daily. Like some months I would do nothing, other months I would do a lot, but I just kept it up over time. As of now, I've been like had a few month gaps in between, especially with the holidays. But
Yeah.
even then, I didn't have to study. I just thought about doing this. Yes, I had this idea for this program for a while. I just decided yesterday, let's just start it off, and then I just put this question. I was able to solve it because I already learned those foundational things, and then I repeated it enough to kind of stick. I don't think I can forget
Okay.
how to do DFS for a long time. And like seeing it in so many different scenarios and situations, like it starts to stick. Kind of like, if you didn't code in a language for a long time, maybe even 2 years, you might still be able to pick up that language and code again in it without looking at any documentation for the simple stuff. But
Okay.
yeah, it's worth it to like. I think it's more important to like do it for a longer period of time to really build it into your head than it
Yeah.
is to always be doing it. Like once you get that deeper understanding of it in lots of different questions, different scenarios, then it becomes harder to forget, even if you're not doing it like constantly.
Okay. Makes sense. Thank you.
No problem. We got Amy. I don't hear any audio, but I don't see you on mute. Maybe it's something with the mic. Can anybody else hear?
No, I can't hear.
No, she's on mute.
Nah.
Oh, now she muted, but now she's not muted, but I still can hear.
Yeah.
Maybe you have a mic.
It's probably her mic settings or something.
Okay, okay. So for now, let's go to Emmanuel and see if we can figure out the other issue.
Have you seen the issue with the Discord? Is there anything like I can't seem to get any of the other channels? I only have, I think. Oh well, now it's coming back. Now it's on. Sorry, never mind. Oh wait, no. Like I keep getting like this. It has like some errors there, like on the resources and stuff like that.
Oh really?
In the Discord link that you sent.
Interesting. Let me see. Maybe it's the wrong channel that was on when I pressed.
Maybe
the
some
button.
channels are off, right? Could it be?
That's weird. Yeah, I'll look into it afterwards, and then I'll send an email out with the link.
Okay, thanks.
Cool. Almost running into my next meeting, but a few more. Mail.
Yeah, I got that too. Thank you so much for your time. I really appreciate it.
No problem. So one person has their hand up, but they didn't say anything yet. Emmanuel.
Yeah. I'd like to ask a question. If that's okay.
Sure.
I hear that when you're solving these problems, the interviewer wants you to walk through your solutions as you're going through the problem, right? But sometimes I find that I want to sit still and think deeply. But I hear that they just want you to talk about everything, even when you have a block and all of that, right? So how can you like not take a while and say, okay, fine, I just need to clear my thoughts. I'm just so confused. Must you like talk at all points, like communicate your process?
Yeah, I highly suggest to talk at all points because when you're talking, thinking to yourself, they're not knowing where you're going, so they can't help guide you, and they're also missing on those insights. A lot of times, like the only thing they're really looking for is how do you think and how do you solve problems, and that's how they're gonna figure that out by hearing how you're solving the problems. So if they see you breaking it down very logically, step by step, that's gonna give a very good signal to them. And then if you're going in the wrong direction, they'll be able to guide you into the right one. And also, they need to understand what you're thinking so that they'll follow your solution because they might be thinking, "Oh, this is not going to work," because they didn't hear you. They didn't know your plan of attack. They don't know what you're going to do. So they may have a negative bias and like, "Okay, what is this? I'm not sure what's going on." It's harder for them to evaluate. So you have to be communicating with them because you're kind of working with them to get through the problem. So that's why there's so many reasons why it's so important to be able to just say it out loud. And it's not easy to do at first, so that's why mock interviews are very useful. Like I do like all the time. I say it's useful because I have a lot of anxiety sometimes. Like when I was doing these interviews at first, but because I did so many of them, it just started to become natural and you feel normal. And that's why I realized like it's an important step to do a lot of these practice interviews, especially if you're trying to code and talk at the same time, or it's a lot to juggle if you're not used to it.
Oh, okay, I see. Thank you.
No problem. All right, one more question before we go, if anybody has one.
Hey, Esco, I got a question. I mean, I asked one earlier, but yeah, all these data structure and algorithm questions, it's cool to be able to solve these problems, but could you say solving these problems unlock positions no matter whether it's, front end, back end, or, specific purpose? Like say you get to a FANG company and you get past these type of questions, what's next? Like, how are you placed in like front end, back end, or a specific role? Or are there like another set of questions that now you need to focus on particular to, whatever focus you plan on going down?
That's a good question. So Google's the one, probably Meta too, I believe. Those are the ones where they really go hardcore on the data structures and algorithms for front end developers as well as back end. Other companies like Airbnb, they kind of shy away from doing the data structures for front end developers, although it does come up a lot. It still comes up in the question, just not very explicitly. So whether you're doing front end, back end, it's still very useful to be able to pass these type of questions. And as far as the assignment, is you really apply to the role. So you're applying to a front end role directly. So before you even get the interview, you already know what kind of role you're going to be in. But when it comes to teams, some companies they shift you on teams depending on after you pass and after you talk to different teams, like team matching. Airbnb does that, but they also do predefined teams as well. They do both models. Google, I believe I know they do team matching generally speaking, but I believe you could, in some cases, target a specific team. But the role is always known upfront. When you first do call the recruiter, and when you first apply to the company, you have to apply to a specific type of role, whether that's like back end or front end, or mobile,
Understood.
or data science, where it is.
Understood. Appreciate that insight.
No problem. All right, this is fun. Hopefully, we got some people who fill out the form that said they want to be volunteers. So I'm going to reach out to some people for one for next week, and might even do like sooner than that for the other ones. Where I was talking about DFS and recursion, just to get some fundamentals. So I'll be in touch through a group and then through the Discord and the email list if you sign up.
Okay, looking forward to it.
Where
Thank
can we
you.
for the volunteer?